Alright, in this example, we are looking at Phasors in parallel, and we are looking at a combination of a capacitor, inductor, and a resistance all connected in parallel. So this example will show us how we can calculate for the current in each branch, the total current, and the phase angle between the resultant current and the supply voltage. So without any waste of time, let's look at what this circuit will look like. To look somewhat like this. So we can see the value for our resistor, inductor, and capacitor from the circuit here. So here we have 20 microfarad, and we have 0.13 Henry, and then resistor of 50 ohms, all connected to our power supply here, which is a 230 volt 50 hertz supply. So we are asked to calculate for the current in each branch. That means particular value of current flows in each branch. So let's say they are IR, IL, and IC. And at the end of the day, we want to get the total current, which is obviously I, that is flowing into the system. From there, we can get the phase angle between the resultant current and the supplied voltage. So jump right into it by calculating first the current in each. So let's start with the current flowing through the resistor, which is IR. This can easily be gotten from the value of voltage using our Ohm's law. So the value of current can simply be gotten from V all over R, which is straightforward, 230 divided by the value of our resistor, which is 50. Okay, if I punch that out in my calculator as 4.6 amps, okay, that will solve for the first current here. So let's call this I. So II, we can now go for the current across the inductor, which is IL. This can also be gotten by dividing voltage by the inductance. So first off, we're going to get the value for our inductance, and this can be gotten from 2 pi FL. So if I bring this into the system, so what we are looking at is the value of voltage, which is 2 then our voltage all over the value for pi times 50 multiplied by our 0.13. Punch this out. Okay, this should give us the value of 5.63. Up next, we're going to get the value for our current flowing through the capacitor, which is IC, and of course we can get that from the voltage all over XC. This is the same thing as from SC, which is equal to 1 over 2 pi FC. We can say that our IC is therefore V all over 1 divided by 2 pi FC, which is the same thing as V 2 pi FC. So if I substitute my values, I will have the voltage here is 230 multiplied by 2 multiplied by pi times frequency, which is 50 multiplied by 20 times 10 raised to the power minus 6. We can get the value. We can then get the value as the value as 1.45 amps. You can see that each components draw a particular value of current, and we've clearly gotten them now. So moving forward, we're going to get the value for the total current. The total current here is simply the resultant current that is actually flowing when we have our graph. So to get this, we are going to refer to the graph very quickly. The phasor diagram should look somewhat like this, where is our voltage, of course, that is leading, and you know that our IR is always in phase with voltage, with the supply voltage. So let's say this is the value for our ICIL. So the resultant current will be this way, which is I. In this case, you can see clearly that the value of our IL is greater than IC. So we say IL minus IC here. And this is our phase angle, which is the angle between voltage and the resultant current. Okay, so we can see that here is our IL minus IC, which happens to be the opposite, and we have our adjacent as IR, and L becomes the hypotenuse. So we can easily derive an expression where our I square is the same thing as IR square plus IL minus IC square, which is Pythagoras theorem. So we can use that to solve for the total current. So the total current I will now be equal to the root of IR square plus IL minus IC square. So I'll quickly insert the values, and the values here is 4.6 square plus 5.63 minus 1.45, everything squared. Then we'll get the root. So this would give us 4.6 square plus 4.18 square. So our I will give us 6.22 amps. So with that, we can see that we have gotten the value for our total current. So for still looking at this graph here, it is easy for us to get the value for our phase angle. So the phase angle, which is number 3, can be gotten from this graph. So we can get it from tan inverse, where we have opposite over our adjacent. Opposite over adjacent, what is the opposite here? Opposite is the value of IL minus IR. Obviously, this is the opposite over adjacent, which is IR. So that can easily be gotten from that. So what do we do? This angle. What is IL minus IR? 4.18. And what is our IRL? This we can see is the same thing as the tan inverse of this minus this all over, which is the tan inverse of 4.18 all over